Hi boys and girls, today we are learning about math, lesson 107. Okay, 107, adding and subtracting fractions and mixed numbers, okay, with common denominators, okay. So, in your book it tells you can think about it on page 675 and 676. It says, when adding fractions, it helps to think of denominators as objects, okay, such as apples. Just as one apple plus one apple equals two apples, okay, 1/3 plus 1/3 equals 2/3. And then they give you the picture of that on page 676 at the top, and you can look at that, okay. One apple plus one apple is two apples, okay. So then they say 1/3 plus 1/3 is 2/3. I already kind of showed you guys this in a prior lesson, but I'm using some pictures and we're going to get right into this. It says when we add fractions and we add the numerators, the top numbers, but we do not add the denominators or bottom numbers, and that's when we have common denominators. We're not going to add those when we're adding fractions like that, okay? So we're going to get an example one. It says Blake mixed 3/5 pound of cashews with 1/5 pound of pecans. What is the weight in pounds of the cashew and pecan mixture? So we're adding two different weights, okay? So if we look at that, okay, and we have this, we have 3/5 plus 1/5 equals what? Okay, now we can think about this problem like 3 plus 2. Okay, I can write it horizontally, equals 5, or I can write 3 plus 2 equals 5, okay? So we can see it horizontally and we can see it vertically, okay? Now I have some pictures here in some different colors, okay? So we've got 3/5, which I've got shown by the orange, okay? 1, 2, 3, 3/5, right? So that's 3/5. And then 1/5 plus 1/5 plus 1/5 is going to equal, well, let's look at that. If we take all three of these, okay, and we add them, 1, 2, 3, okay? So they have moved over there, okay? And then we take our 1/5, okay, and we move that to right there. What do we end up with? Okay, we end up with a total of 4/5. So 3 plus 1 is 4, and you keep the same denominator, fifths, okay? Now we can think about that vertically as well. 3/5 plus 1/5, we add the 3 plus the 1, which equals 4, and we keep the same denominator, which is 5, or 4/5, okay? So that's example 1, okay? Example 2, okay, and reads, to make a small bow for a present, Denitra cut 1/5 of a yard of ribbon. So she had a whole yard of ribbon, right? What's a yard? Okay. A yardstick has 3 feet in 1 yard. We chanted that for a long time, okay? 3 feet equals 1 yard. So she has 1 yard, and she cuts 1/5 of that, okay? So she's going to take this yard of ribbon and divide it up into 5 pieces, okay? And 1/5. She takes 1/5 of that yard. She cut 1/5 of a yard of ribbon from a length of ribbon that was 3/5. So she didn't have a whole entire yard to begin with. She only had a fraction of it, a part of it, 3/5 of it, okay? And what is the length of the ribbon that was not used for the bow? Okay, so now we get subtraction, okay? That's just a tiny bit different when we were looking at that, okay? Drawing pictures of that. So what we did last time, okay, we ended up having 3/5 minus 1/5. Okay, so we start with 3/5. We start by not having the entire thing, okay? And we are subtracting 1/5. Okay, so when we think about this, this is each of these pieces is a fifth. 1/5, 2/5, 3/5, 4/5, 5/5. 5/5 equals the whole thing. So we're starting with only 3 of them. So if we just subtract 1, we take 1 away, we're left with 2/5. Okay, we have that equaling 2/5. Okay, so that's how we do that. We just take 1 piece away. 3/5 minus 1/5. So we do 3 minus 1 is 2. That's my numerator. Numerator north. Okay, north. Denominator down. Okay, so Now I need my denominator. My denominator just stays the same, 2/5. My answer's 2/5. Okay? So to see that, numerator and denominator. Okay? So that's how we remember the north numerator, down denominator. Okay? So north is always up on a map, so the numerator is always north on the fraction, so it's the numerator. Okay? That's going to get in our way in a second here. Okay? So now we have example 3. Okay? Let's put that to example 3 and see what the problem is. Okay? In your book, it says example 3, add 2 3/5 plus 3 1/5. Okay? So let's walk through that as the example problem on the board here. Okay? So what I did, I drew a picture of that. 2 holes, okay, so 2 whole pizzas, 1, 2, and 3/5, so 3/5, okay? Now we had seen what 3/5 looked like over here, okay, so it was the orange pieces, okay, so we could imagine that that was over here, okay? Plus 3, okay, 1, 2, 3 whole pizzas, whole pies, whatever you want to think about, whole, okay, and 1/5 and 1/5, okay, so we're adding those together, okay, so what do we end up with? Okay, so if I add my whole pizzas, I have 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 whole pizzas. Okay, so that was 1, 2, 3, 4, 5. Now I have my fractions left. Okay. So when I combine 3/5 plus 1/5, oh, check this out. It was the same problem. 3/5 plus 1/5. Okay, my 3 oranges, brought it over there. My 1 blue, brought it over there. That equaled 4/5. So what does that equal? Okay, on this partial, that equals 4/5. So what is that answer? Okay, it is 1, 2, 3, 4, 5, and 4/5. So it equals 5 and 4/5. Now when I look at that, 2 plus 3 is, okay, if I had to color this out, okay, 2 plus 3 is 5, okay, and 3/5 plus 1/5 is 4/5, okay. How do I get that? 3 plus 1 equals 4, okay, and the denominator stays the same, fifths going across there, okay. To look at this problem, if you just saw it, without the pictures, and this was the problem in your book, and you had to do this, it was like number 22 or something like that, okay, you would say, okay, what's 2 plus 1? 2 plus 1 is 3, and then you'd have 3/5 plus 1/5, okay, so to think about this, okay, I have my 3/5 plus my 1/5, which equals 4, okay, and my denominator stays the same because I'm still out of 5, okay? Now one thing I'm going to show you here, if you make your 3 too small, okay, that kind of looks like 34/5. That's not what our answer is, okay? So we have to make sure our 3 is the same size as the fraction there, okay? So that we kind of come across and we have the same size there. So 3 and 4/5, okay? But I messed up there. That says 2 plus 3. This should say 2 plus 3. Okay? So what is 2 plus 3? It is 5, okay, and 4/5, which is exactly what we got right here. 5 and 4/5, 5 and 4/5. Okay? So that's example 3. Now let's move on to example 4. It says subtract 5 2/3 minus 1 1/3. So 5 2/3 minus 1 1/3. Okay? So we can see that horizontally, like the horizon. Remember, we look this way for the horizon. Horizon is in the word horizontal. That's how we remember that. Vertical is, how high can you jump? That's your vertical, so it's up and down. Okay? That's how we kept those straight at the beginning of the year. Okay? And so we got 5 2/3 minus 1 1/3, or 5 2/3 minus 1 1/3. Okay, so I drew that out. Here's 5 whole pizzas, and my starting point, and 2/3. Okay, so to look at this, okay, and I have to take 5 holes minus 1 hole. Okay, so here's my 5 holes. I need to subtract one of them. So one whole pizza goes away. Oh, yum, that was so good. I did that the other day. Mrs. Mondale made homemade pizzas, and she made me my whole pizza, and I ate way too much, and I was miserable the rest of the night, but it was so good. Okay, so now I'm at 5 wholes minus 1, remember I erased it, is down to 4, okay? And then we have 2/3, okay, minus 1/3. So we start with 2/3 right here, 1, okay, and we gotta subtract 1, get rid of 1. So what do we end up with? 1/3, okay? So 4 and 1/3. That's what it would look like in pictures and how we would do that, okay? So now if we just have the simple numbers, just so we can see what happens there. 5 minus 1 is, that's 4, okay, I'm gonna make it a little bit bigger, 4. And then 2/3 minus 1/3. So we do the 2 minus the 1 is 1. And the denominator is 3, so that stays the same, 1/3. Same answer, okay? Now we can also see that right here. Okay, 5 minus 1 is 4. Okay, those are the whole numbers. That's when we had 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we subtracted 1, right? What do we end up with? 1, 2, 3, 4. That's our 4. Okay, and we started with, okay, the red one here. Okay, 2/3. We started with 2/3, and we subtracted 1. Okay, so we subtract 1, so we have 2 minus 1 is 1. Okay, is 1, and we have our same denominator. Okay, it's still out of 3 pieces there. Okay, so 1/3, 4 and 1/3. So our denominator stays the same, 3. 2 minus 1 is 1, so we have 4 and 1/3. You can kind of show those either direction, okay? Now we move on to our final problem here, example 5. It's a story problem. Okay, I'm just going to read this to you. It says, in the race, Martin rode his bike 7.5 miles, 7.5 miles, and ran 2.5 miles, okay? That's a long ways. Mr. Mondo went for 3 1/4 mile run here a couple days ago. Okay, so it's doable. Okay, and you guys could do that too. Okay, in a race, he rode his bike 7.5 and he ran 2.5. All together, how far did Martin ride his bike and run? Okay, so we're looking at that. If we had to think about this, okay, these obviously aren't miles, right? I drew pizza, so we could say he ate 7.5 pizzas and then 2.5 pizzas. Okay, so if we had to think about this as miles, okay, here is 0, 1, 2, 3, 4, 5, 6, 7, okay, 8, 9, 10, and we'll just stop it there, okay? He ran 7.5, okay, so we can see this on the number line. So there's 1, 2, 3, 4, 5, 6, 7. This is 7, okay? And he ran 7.5, okay? So that means he's right there, okay, at 7.5. And then he added another 2.5 to that, okay? So he goes from 7.5, okay, to 8.5 to 9.5. Okay, so that's 2. And then he has to add a half more. So that would end him, looks like, right at 10, okay? And we can kind of see it that way too, okay? Because halfway between 7 and 8, 9, okay? 6, 5, 4, 3, 2, 1. Halfway between 1 and 2 is 1.5. Halfway between 2 and 3 is 2.5. You guys can kind of see that, okay? So let's see what happens here, okay? And see if we ended up with 10 miles, okay? Like that, okay? So we have 7.5. I got 1, 2, 3, 4, 5, 6, 7. Okay, and 1/2. I have my red half. Plus 2, 1, 2, and my half. I did that one in blue. Okay, so we add that up. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 holes. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 holes. Those are still complete pizzas, okay, or complete miles that we ran, okay? Okay, we could take these circles and put them the other direction. It'd be like having, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 miles. 9 whole miles that he's ran so far, okay? He just ran and biked all that far, okay? So he's got that. So we got the 9 holes. Now, okay, we have the half, the red half, plus the blue half, okay? So if we take the red half and we bring him over to this side, okay, and then we take the blue half, okay, and we bring him over to that side, okay, suddenly a half plus a half is one whole, okay? So that becomes 10 right there. There's 10, okay? So now this half and half moves over and we're at 10, okay? So it's 10 miles, it would be my label, okay? So now let's look at this in terms of what would it look like if I was writing out the fractions and the whole numbers just with the numerals, okay? We would do 7 plus 2, that's 9. And then we have 1/2 plus 1/2. So we add the numerators, 1 plus 1, okay? And I'll just do that in red. 1 plus 1 is 2, okay? And then we do the denominators always stay the same. Okay, we have 2 over 2. Well, what is 2 over 2? Okay, 2 over 2 is simply 2 divided by 2, or 2 divided by 2, or 2 divided by 2. What do all those equal? 1, 1, 1. So this is 9 plus 2 over 2 is 1. 9 plus 1 equals 10. Okay? Not too hard. Okay? Now we see the same thing here. 7 plus 2 is 9. Okay? And then we do our numerator plus our numerator, okay? Which is 1 plus 1 is 2, okay? And the denominator always stays the same, which is 2. Okay, now I have 2 over 2. 2 divided by 2. How many times does 2 go to 2? Okay? Well, I can think about it as 2 out of 2, okay? Or 2 divided by 2 is 1, okay? So this stands for 1. I still have 1 whole, and I still have my 9, okay? So those two now add together to equal 10. And so how far did he run and bike? 10 miles, okay? So that's your new concept, okay? It is, I think you're gonna find it to be fun. These problems are enjoyable, just kind of a different way to add than what you've been used to. So have fun with today's math lesson. Again, this is math lesson 107, and you may now do the lesson practice and check that yourself with the key that's on the classroom assignment, and make sure you understand it before you start your assignment. And let me know if you got any questions. Thanks. Bye.